Hello student, this video is for class 9th student. This video is the third part of chapter number 9, which is force and laws of motion. Into the first two parts, we cover about force and first law of motion. Into this part, we will cover second law of motion, third law of motion and conservation of momentum, which is also a very important topic of the chapter. So let's start. Before study the second law of motion, the first topic arises momentum. So what is momentum? Momentum is the product of mass and velocity of an object. Momentum is the product of mass and velocity of an object. It means if an object has mass m and it is moving with a velocity v, then the product of mass and velocity is known as momentum. Momentum is a vector quantity. Its direction is same as that of the object velocity. Momentum is a vector quantity and its direction is same as the direction of velocity. It is denoted by small p. SI unit of momentum is kilogram meter per second or kg/m second inverse. Formula of the momentum will be p is equal mv. As you can see by the definition, momentum is product of mass and velocity. So mass multiply velocity is equal momentum. So formula will be p is equal mv, where m is the mass of the object and v is the velocity of the object. Now, momentum of a stationary object. As we know, momentum is the product of mass and velocity. So what will be the momentum of a stationary object? In such case, suppose a ball is stay on the floor, so the velocity will be 0. So what will be the momentum? Let the mass of the stationary object be m and the velocity of the object be v. Into the stationary condition, object has no velocity. It means v is equal 0. So therefore momentum will be p is equal mv and v is equal 0. So what will be the momentum? Momentum will be 0. So the momentum of a stationary object is 0. I hope the point is clear to everyone. Now we will study about the second law of motion. What did second law state? According to the second law of motion, the rate of change of momentum of an object, I am repeating again, the rate of change of momentum of an object is directly proportional to the applied unbalanced force. Rate of change of momentum of an object is directly proportional to the applied unbalanced force. So what is the application of this law? So let's take an example. In this example, you can see into the picture that a fielder is trying to catch the ball. So a cricketer, when catches a ball, pulls his hand in the backward direction to decrease the velocity of the ball. Now as you know, change of momentum is directly proportional to the unbalanced force. So when a cricketer catches a ball, he pulls his hand into the backward direction to decrease the velocity. As the acceleration of the ball decreases, the force exerted on the catching the moving ball also decrease. So as the velocity will decrease, similarly acceleration will be decrease. And when acceleration will decrease, force will also decrease. If the cricketer would try to stop a moving ball suddenly, he would have to apply larger force. If cricketer want to stop a moving ball suddenly, he would have to larger force. So I hope the example is clear. Now we will see mathematical expression for the second law of motion. It means how to calculate mathematical formula of force. Suppose an object of mass m is moving with initial velocity u and its initial moment will be p1. After some time, velocity become v. So the final momentum will be p2. By this, we can conclude the initial moment p1 is equal m multiply u and final moment p2 is equal m multiply v. So the change in momentum will be p2 minus p1. It means mv minus mu. We can take m common. So change in momentum will be equal to m into v minus u, where m is the mass of object, u is the initial velocity and v is the final velocity. Now further, according to the second law of motion, we know that force is directly proportional to the rate of change of momentum. By this, we can make an equation like force is directly proportional rate of change of momentum. So rate of change of momentum, it means change in momentum per unit of time. So force is directly proportional mv minus u, which is change in momentum upon time. So it will be the rate of change in momentum. Now force directly proportional will be m into a. How the a comes? As we know, a is the acceleration and formula of the acceleration is v minus u upon t. By this, we can conclude that force is directly proportional m into a. Now F is equal k ma. What is k? K is a constant. For 1 unit of force, k multiply 1 kilogram, and what is the acceleration? 1 meter per second square. So the value of the k will be 1. For 1 unit force, the value of the k will be 1. If we put this value into the equation number 1, what we will get? We will get F is equal ma, and it is the formula of the force. So we can say the force is equal mass multiply acceleration, or the product of mass and acceleration is considered as force. Now we can conclude that force is directly proportional acceleration. Force is directly proportional to acceleration. So as the acceleration increase, force will increase. If the force is decrease, acceleration will also decrease. What is the SI unit of force? The SI unit of the force is kilogram meter per second square, or it's a simple unit, Newton, denoted by N. So what is the SI unit of force? We can say Newton or kilogram meter per second square. Now the third law of motion. What is action and reaction force? Before study the third law of motion, we will study about the action and reaction forces. Two forces acting from opposite direction are called action and reaction force. When two forces act from opposite direction are called action and reaction force. For example, a ball when hits the ground bounces back with a certain force. When this ball hit the ground, it bounces back with a certain force. So in such condition, when ball hits the ground, it is the action, and when ball bounces back, it is the reaction given by the floor or the ground. So one force is action force and the other force which exerted by the ground is called reaction force. Now what is third law of motion, or what is the statement by the third law of motion? So what is third law of motion? It states that when an object exerts a force on another object, the second object instantly exerts a force back onto the first object. It means if an object a force on another object, so the second object will also exert a force back onto the first object. These forces are always equal in magnitude but opposite in direction. These forces are always equal in magnitude but opposite in direction, and these forces act on two different objects always. Because they are acting on each other, so we can say they are act on different object always. In short, third law of motion states that for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. Law of conservation of momentum. As per the conservation of momentum, the momenta of two objects before the collision and after collision remain the same. given no external unbalanced force acting upon them. So according to law of conservation of momentum, the conservation of the system before collision and conservation after the collision will be same. Now the topic is law of conservation of momentum. As per the law of conservation of momentum, the sum of momenta of two objects before the collision and after the collision remains same, given that no external unbalanced force acting upon them. It means the momentum of two objects before the collision and momentum of two objects after the collision will be same. The condition is that no external unbalanced force acts upon them. It means no external force acting upon them. Mathematical expression for the conservation of momentum. Consider two balls A and B having certain initial velocity collide with each other. Condition before the collision. There is no unbalanced force acting upon them, and the second condition, the initial velocity of A is greater than the velocity of the B. So what will happen? Suppose that there are two balls of mass m1 and m2 and their initial velocity is u1 and u2, and statement considered as u1 is greater than u2. During collision the momentum will be this, and after the collision they are moving with the velocity of v1 and v2 respectively. So the momentum of ball A before collision will be ma ua. Momentum of ball B before collision will be mb ub, and momentum of ball A after the collision will be ma va, and momentum of ball B after the collision will be mb vb. Rate of change of momentum of ball A. What will be the rate of change of momentum of ball A? Will be ma va minus ma ua. So we can also write this ma va minus ua upon t, which will be equal to the force of reaction FAB. Rate of change of momentum of ball B will be mb into vb minus ub upon t, which will be equal to the force of reaction FBA. According to the third law of motion, force of reaction is all AB FAB minus होगा force of reaction FBA. Negative sign show opposite force. MA into VA minus UA upon T is equal minus MB into VB minus UB upon T. MA VA minus MA UA is equal minus MB VB plus MB UB. You can see I just multiply MA inside the bracket. After that I am moving this term minus MBVB to this side. So what will be the equation? MAVA plus MBVB is equal MAUA plus MBUB. So now we can also write it like this: MAUA plus MBUB is equal MAVA plus MBVB. So momentum before collision is equal momentum after collision, and it is proved. Now application of law of conservation of momentum into a system of bullet and gun. So according to the law of conservation of momentum, into the case of bullet and gun, momentum before fire will be equal to momentum after firing. So MAUA plus MBUB is equal MAVA plus MBVB. Because before firing momentum will be 0, because both gun and bullet is in stationary condition, and into the stationary condition MAUA will be 0 and MBUB will be 0 because of initial velocity are 0. And so putting the initial velocity 0, momentum before firing will be 0. which is equal to MAVA plus MBVB. From this we can make a statement MAVA is equal minus MBVB. So by this we can conclude that if the bullet is going into the front of the gun, then there will be a recoil velocity of the gun into the opposite direction of bullet, like this. So if the bullet is going into the forward direction, there is a recoil velocity of the gun into the backward direction, which produce a shock. In all of the condition, MA is equal mass of the bullet, MB is equal to mass of the gun, UA is equal initial velocity of the bullet, UB is equal initial velocity of the gun, VA is equal velocity achieved by the bullet when fired, and VP is equal recoil velocity of the gun. I hope these topics are clear to everyone. Thank you so much.